All right, hello, welcome. So today our first topic that we're going to be talking about, we're going to talk about percentages. Okay, so we're going to delve in, well, what is a percent? How do we calculate different percents? How do we go from decimal to fraction to percent? Right, so all of these topics are going to be covered in our first lesson here. We're also looking into some basic word problems and identifying, right, what it is that we're looking for and how to calculate. And then the last thing that we're going to go into for this lecture is the difference between absolute and relative change. Okay, so let's get started. So today we're going to talk about percents. So again, just the straight up definition of a percent is simply per 100. Right, so when we interpret when something says 15%, right, what that implies is 15 over 100. All right, so just think of the per as a division. All right, so what we're going to do in this section is we're going to work through on some basic percent problems, then we'll move and do some more of application-based problems. Right now, a basic percent problem would be something like calculate. So an example would be, what is 30% of 75? Okay, so this would be kind of a basic problem. There's no kind of story behind it. It simply asks you to calculate a number, right? So they give us a percent, right? Always easily identifiable for that percent symbol. Okay, so here, when we kind of read this, we say what, all right? So that's what we're looking for, right? I don't know, right? What is? All right, so this is my unknown. Okay, now when working through these problems and you want to identify some key words here, two that should stick out here are the is. All right, and when you see that, for the most part, you want to think of equals. All right, and when we see the word of, we want to think multiply. All right, so that's kind of how you want to interpret some of these keywords in these basic percent problems, right? Now, in terms of, well, we have an unknown. So when you have an unknown, you want to think of a variable, right? We want to introduce a variable here, right? So unknown, right? We can think of x, our variable, or really any other letter that you would like to name it, right? Once we get to doing problems that involve some kind of story, you like to choose a letter that describes the variable that we're trying to solve for. All right, now putting all this together, you can see, all right, so now putting it together, the unknown x is equals. All right, so now in this case, we have a percent and we want to make sure that we change it into a decimal or a fraction, right? When working and calculating these values, the percent isn't something that we're going to, or in the percent form, isn't something that we can do the calculations with, right? So in decimal form, 30% is equivalent to 0.30. All right, so it's moving the decimal place 2 places to the left. All right, and again, so 0.3 of multiply, so I write these set of parentheses to signify multiplication, and then we have 75. Okay, so now I'll put this into my calculator, and actually let me bring up my calculator here real quick. Okay, let me clear this out. So we'll have, I'll plug in 0.3 times 75, and then I'll hit enter. Okay, and we get 22.5. And again, you can write it just like I have it written in the notes, where we can plug in 0.30. All right, close parentheses, open another parentheses, 75. And we see that gives us the same result. And again, another kind of way to represent the same operation is we can write 3 and maybe Now we open a set of parentheses, 75. Oops. Excuse me, 0.3 times 75 equals, let me see, we get 22.5 or 22 and 5/10. Okay, any one of those calculations that you see there are equivalent. All right, so now we go back here and we could say, all right, x is equal to 22.5. All right, and that is a basic percentage problem, right? So what we notice here is we went from a percent to a decimal, right? And here we can go from a percent so we want to kind of establish the rules. If I do start off with a percent, I want to make sure, all right, can I go from a percent to a decimal? Right, and another representation of a percent would be in fraction form. All right, so here we want to say, all right, how can I go from percent to decimal, but also the other way around, right? And then from percent to fraction, and then from fraction to a percent. Right, and here. Okay, and then if needed, we can always go from decimal to fraction and fraction to decimal. Okay, by just understanding what these numbers represent. All right, so now let's start with a percent. All right, so let's say that we had here okay, regardless of what the percent value is, when we want to go from percent to a decimal, right, we are always, right, even though it's not shown here, it is implied that it's 35 and the decimal goes right there. Right, regardless of what the decimal is, or excuse me, what the percent is, we are always going to move the decimal place value 2 places to the left. All right, again, this is equivalent to dividing by 100, which is exactly what a percent is, right? So looking at this 35% written as a decimal is equivalent to 35 hundredths, right? And again, there's that per 100, right? Hundredths, right? So we move that decimal 2 places over to the left. All right, and again, this is regardless of what the percent is. Let's say, for example, what if it was 1.25%? All right, let's see, all right, how to write that as a percent. And again, it's always moved 2 decimal places to the left. So this becomes 0.5, right? Again, if there's not 2 digits to the left of it, make sure you have a placeholder in the form of 0. All right, and those are equivalent. Right, and let's say we had a percent that was greater than 100. Let's say we had 225%. All right, and again, this doesn't change. Right, what we have here is we see, okay, so the decimal again, it's implied that it's there, so we're going to move it 2 places to the left. So this becomes 2, right, without a percentage sign. All right, so what you see here is on the left side of the equal sign are the percents, and on the right are the same percentages, but now in the decimal format. Okay, now let's say we wanted to go in the other direction. Say I wanted to go from decimal to percent. Okay, so in this case, we would say, all right, let's say I do start off with, let's say, this decimal. All right, and I would like to go 2%. Okay, so in this case, if we are essentially performing the reverse operation, right? If you think of from percent to decimal, we move the place value 2 places to the left, but now we're going in the other direction, from decimal to percent. So what this is going to require is the movement of the decimal, but now instead of to the left, we're going to move over to the right. All right? And so that is that here, we'll get 48%. All right. And again, regardless of what the initial decimal is, it's always 2 places to the right. All right. And that'll get us our percent. All right. So for example, let's say we have this 7/10, right, or 0.7. All right, so something like this, to change this to a percent, we're going to move it over 2 places to the right. So that means that here we'll have, again, if there's nothing there, add a 0 as a placeholder there. So we'll have 70%. All right, and let's say that we had a number that is greater than 1. So let's say we had 1. All right, and this is the decimal form, right? It's a decimal or a number greater than 1, but it's still in decimal form. And again, right, rule is the same. What do we do from here? 2 decimal places to the right. 2. So now this becomes 138%. Okay, and here what you should take from this is that any number that is greater than 1 or 1 or larger is going to be a percent greater than 100. All right, and any percent number or any number that is less than 1 is a percent that is less than 100. Okay, now if we had, let's say, a fraction. All right, or let's start with, how about we go from percent to a fraction. Okay, so let's start with 27%. Okay, and I want to change this into a fraction form. Okay, so again, right, percent means per 100. So this is equivalent to 27 over 100. All right, and in this case, this is already in lowest terms. So one thing that I do ask of you is that whenever we're working with fractions, is just make sure that if we're asked to give a fraction, that it is always in lowest terms. And this is, in fact, in lowest terms. Right. And the reason I know that is that the only factors of 27 are 3, right? 3, 9, 27, and 1, of course. But those don't go into 100, so it cannot be reduced any further. Okay, so this is in lowest terms, and that is how we go from a percent to a fraction. Now, let's say that you are, or it is not in lowest terms, so how would I approach that? So let's say we have, how about 12%? And I would like for it to be in a fraction in lowest terms. So I would write 12 over 100, but right away I know that this is not in lowest terms. Both of them are even, so that means they have a common factor of 2. Now, one thing that will kind of really simplify finding things in lowest terms is by the use of technology. So I'm going to bring up my calculator again. And in my calculator here, you see, all right, so my calculator, I'm going to turn it on. And we have 12 over 100. Remember, a fraction is nothing more than a division problem, right? Now, if I hit enter here, I get back a decimal, which is not what I want. All right, I actually want a fraction in lowest terms. Now, the nice thing about a calculator like this is that this will do all the hard work for us. So I'll type in 12 over 100, but in this case, before hitting enter, I'm going to go to this menu here, math, and the first one has this little arrow or triangle and the words frac for fraction. So what that does, so you can hit 1, is it takes any fraction or even any decimal and it will give as an answer the fraction in lowest terms. So hitting enter here, we see, there we go, 3 over 25. And that is equivalent to here, our fraction here, 3 over 25, right? So one thing that I want you guys to realize is that, well, actually, all of these, those are all equal, right? That's what equality means, right? Equal means that you can use those interchangeably, right? 12%, the same as 12 over 100, the same as 3 over 25. All right, those last two fractions, these are what are known as equivalent fractions. All right. Okay. So they represent the same thing. I will be looking for in your work that you represent the fractions that you give them to me in their lowest terms. So I'll be looking for this result here, 3 over 25. Okay. So what about from fraction to a decimal? Excuse me, let's fraction to a percent. Okay, so let's say that I wanted to do 1/5. And I wanted to see, all right, what is that percent? Now, the quickest way here, again, we have technology available to us or in the form of a calculator, is let's say that we had, all right, 1 over 5, right? Again, remember, fraction, nothing more than a division problem. We hit enter, and as a result, we get 0.2 or 2/10. All right, so I have this intermediate step because as we saw in the previous problem is now that I have a decimal, to get to a percent is simply moving over 2 decimal places to the right. So in this case, and again, for any place value, you add a 0 that is empty, so we get 20%. All right, and this will go for any fraction. Let's say we had, how about 12 over 8. Okay, and let's say that I wanted to write this fraction as a percent, so I'll go to my calculator here, and we have 12 divided by 8, and we get 1.5. And again, right, this is the decimal, so to get to the next step, move over 2 places to the right. All right, and that gets us to the percent. All right, so now we can work interchangeably from one form to another, whether it's from fraction to percent, from percent to fraction, or any other iteration, decimal to percent, percent to decimal. Okay, so now let's take a look here, and let's do, here, let me bring up the kind of definition here, how the book describes, so I'm gonna scroll over here. So percents. All right. So the way I want you guys to think of these percents is percent. Think of the part over the whole. All right. If we think of here the fractions that we have here, the denominator is going to represent the total part of it. Right. So sometimes we're not dealing with out of 100. Right. If it's out of 100, it's always easy. Right. 15 out of 100, 15%. Right. 50 out of 100, half or 50%. Right, but in some cases, it's in a lot of cases, it's not out of 100. So always ask yourself what number is representing the whole quantity, right? And what number is only representing part of that quantity. Even though in certain cases, that part that we're talking about, it may be larger than the whole, right? And that would be percents over 100. Okay, so let's start off by doing a problem that has from the book here. Let's take a look here, and let's try something like this, right? So we have here an application problem that we can do here. Okay. Okay. Trying to get this. There we go. All right. Okay. So here's a percentage problem. It's a bit more involved. There's a story behind it. All right. So let's kind of read through this. It says a TV originally priced at $799 is on sale for 30% off. There is then a 9.2% sales tax. All right, find the price after including the discount and the sales tax. Okay, so this is kind of a multi-step problem, right? There's a few things going on. All right, so we're gonna buy a TV. All right, it's on sale. We get a nice 30% discount. Right, but again, there's also sales tax to be applied. All right, so here we have to figure out, right, there's a few steps to this problem, so which one am I going to do first? All right, so the sales tax is going to be applied onto what you paid, right? So sales tax, keep in mind the way that works, is applied to cost of item. Okay. All right, and again, the cost is not $799, right? Because it is on sale. Okay, so the first thing we're going to do, all right, so the first thing, okay, so the first thing we're going to do is we're going to calculate the sale price. Okay, now we can do this in two ways, right? So it's 30% off. Okay, so keep in mind that is our key distinction that we want to make here, right? So we have 30% off. Okay, so what we can do here is we could say, all right, let me take 799 and I'll just multiply it by 0.3, right? 30%. Okay, remember, always change to a decimal. So again, take out my calculator here and we'll get 799 times 0.3. Hit enter, and we get $239.70, right? I'll write it in this form because we are talking about money. Now, this is not what we're paying for the TV, excuse me, right? What number does this represent, right? Keep in mind, always ask yourself or make sure that you know what it is you're actually calculating. right? So what this number represents, this is actually the amount of the discount. Okay, because that's 30%, right? If it's 30% off, that's how much of a discount you're going to get. All right, so a pretty good discount. Okay, so we're not quite done yet to find the sales price. All right, so now we can calculate the sales price. Right, and again, sell price will be the original price, or let's call it retail price. And then subtract from that the discount. So for our problem, we would have $799, and we would subtract from that $239.70. And again, take out my calculator here. So $799, and then subtract. And here a nice feature here, if you hit second and then enter, which is for the second part would be the blue, the entry part. Oops. Excuse me, let me try that again. So 799 minus, and then second, and sorry, not enter, the negative one here, the ANS, hit that one. All right. Now what that does, it brings back the previous answer. So in this case, the previous line was 239.7. So it'll do that operation, 799 minus 239.7. So hit enter here. And we get $559.30. So now we calculate, now that is the sell price. So we get here, sorry, 559.30. All right. So now we have this is our sale price. Okay. All right. Excuse me. Okay, now I did say there's two ways that we can do this, right? Now, the way to calculate the sales price here, it takes two steps. One, calculating the discount, and then subtracting the discount from the retail price. Now, let's say that all I care about for this problem, sometimes it may be necessary, or we're actually asked what the discount is. But let's say that in this case, I just want to know what the sales price is. All right, so here is another approach. Another approach to find sale price. All right, so I like this approach because it really just takes one step. All right, so if you think of 30% off, what does that actually mean? That means if you think of the retail price is 100%, right? So if you think of it this way, if you think, okay, retail price is equal to 100%. All right, well, if we have 30% off, our discount, that means that we are, if retail is 100%, we take away 30%, that means we are paying 70% of the retail price. All right, and again, right, these calculations are done with percent, so to actually calculate the sale price for the problem that we're working on, so we start with the cost of the TV, retail price, $7.99. But in this case, what I'm going to do in one step, I'm going to multiply, instead of 0.3, I'm going to multiply by 70% or 0.70. Now here, Notice one operation, and as I bring up my calculator here, 799 times 0.7. And notice here we get the same result as we did in the previous way, but in this case it only took one calculation. So here we have $559 with 30 cents. All right, and that is the same answer that I got the previous way. All right, I prefer this way. It's just, as you can see, just quicker to get to our desired result. Okay, so we've calculated the sell price, but again, let me scroll up real quick here. That was not what the problem was asking. All right, it's part of it. All right. So it says find the price after including the discount and the sales tax. Okay, so now we figured out how much we're going to pay for the TV. So we go to the register, they ring us up. How much is that? How much is the person behind the cash register is going to tell us that we owe for this TV? So that is our next calculation. Step 1, we calculated the sell price. So step 2, we're going to calculate the total cost. Okay, so that includes sale price plus tax. Okay. All right. So in order to calculate tax, we first need the tax rate, which was given to us in the problem. So the tax rate is 9.2%. Okay. Okay, so here we could say, all right, so the tax is going to be the cost of item, which is on sale, times the tax rate. All right, so in general, that's how you would calculate the tax, right? Whatever the item cost multiplied by the tax rate. Okay, so here the sale price of our item was $559.30, and the tax rate 9.2%. Again, changed to a decimal. Okay. All right. So bring up my calculator here again. So we'll have 559.30. 3 times 0.092. And that equals to $51. And we'll round up to the nearest cent since we're dealing with money. Right, good rule of thumb, if you're working with money, how many decimal places? Well, 2. That's usually how we, for the most part, how we get charged for money, to the second decimal place. So the tax is $51.46. All right. So again, this only represents the tax. So again, the total price. The way to calculate that, all right, we're going to have, so total price will be the cost of item, in this case our TV, plus the sales tax. Okay, so here we have 559.0 plus the sales tax, 51.46. Okay, so add these two numbers. So here, 51,559.3 plus 51,446. 46, and enter, and a total of $610.76. All right, and again, that is our total price. All right, out the door with the TV, we pay $610.76. All right, excuse me. All right, now similar to step one, there is another way we can do the same calculation where we can kind of minimize the steps here. Okay, so here, let's look at another way to find total price. Okay. All right, now what we're going to do here is we're going to do this in one step. All right, so the way I'm going to do that is we're going to take total price. And I'll start with the cost of my TV. And I'm going to multiply here, all right? What I'm going to multiply is the number 092. Okay. Now, here you might be asking yourself, all right, where did that number come from? All right, what exactly is it that how do you get the 1.092? Well, as it turns out, this is actually this equation up here. Cost of item plus sales tax, but it's in multiplication form, right? The cost of the item is represented by that one, right? Remember, cost of item, 100% of it, right? That is 100% of the cost, and then the tax added to that is the 0.092. All right. So again, in certain cases, they do ask you what the tax is on a certain item, but if all they ask for you is the total price, you can always calculate it this way, right? 1 for the cost of the item, right? And then the decimal part is the tax that is being charged. And you multiply that by whatever it is that you're paying for this, right? Now, let's see if we do in fact get the same result. So moving over here, so I'll start with 559.3 and multiply that by 1.092. All right, hit enter, and there we go. We get the same result, $610 and 76 cents. Same as above. All right. In this case, we got to our result in one calculation instead of taking 2 calculations to get there. Okay. Excuse me. All right. So that is an example of a percent problem here. Now, the next topic we're going to look at here is, so let me look here. We're going to look at the idea of absolute and relative change. All right, so now in a lot of cases, especially, we're reading articles, news articles, or any kind of articles where they express that something has risen a certain amount or dropped a certain amount. Without any context, it's kind of hard to identify, is that good or is that bad, right? So we say, all right, it's, for example, the stock market, right? The stock market dropped 100 points. Well, does that represent a good thing or a bad thing, right? Is that really good, really bad? We would like to kind of quantify that, right? So a nice way to do that is through this process of absolute and relative change, right? Where you compare it to something, right? If let's say that the stock market is trading at 30,000 points, right? That's the total value. And if it drops 100, well, that's not so bad, right? That doesn't seem like that big of a change. But if, let's say, it's only 5,000 and it drops 1,000, for example, then that represents a much bigger part of the total value. Okay, so that is this idea between absolute and relative change, where you put into context, you get some kind of a percent change. So now it's easy to grasp, right? If you think of your grade, right, you know what 70% is as opposed to 30%, right? Instead of thinking it in terms of raw, just data, right? So let's kind of work through an example here. Again, we'll take one from our textbook here. Here. All right, so here. Okay, so in this problem, it states the U.S. federal debt at the end of 2001 was 5.77 trillion and grew to 6.2 trillion by the end of 2002. At the end of 2005, it was 7.91 trillion and grew to 8.45 trillion by the end of, let's not write, 2003, I believe that should be 2006, and then, okay. Okay, calculate the absolute and relative increase for 2001 to 2002 and 2005 to 2006. Which year saw a larger increase in federal debt? Okay. Excuse me. Okay, so again, the term absolute means that it's not assigning a positive or negative value. All right, so it's not stating whether it was a positive growth or a negative growth. It just says absolute, right? So let's take a look at, so two different things they're asking us to calculate and then to make a comparison. All right, calculate the absolute and the relative increase for 2001 to 2002 and 2005 to 2006. So let's start with 2001 to 2002. Okay, and absolute change. All right, so if we look at our formula, it says ending quantity minus the starting quantity. So here, the ending quantity is 6.2 trillion, right? And then the starting quantity was 5.77, right? And again, those bars at the end represent the absolute value. And again, all that is saying is that whatever the result is when you plug that into your calculator, if it's negative, just ignore the negative and take the positive value of it. Okay, so 6.2, let's take our calculator here. So 6.2 minus, what was it, 5.77. All right, so we get 0.43. And again, this is in trillions of dollars, right? So $0.43 trillion, also actually $430 million is what that actually corresponds to. Okay, and again, that is the absolute change. Now let's calculate in terms of the relative change. All right, again, comparing it to the starting quantity. Is this good? Is this bad? I mean, I'm not sure. It went up, but I mean, how much did it? What is the actual value there? So relative change. All right, so looking at our formula, absolute change, which was $0.43 trillion, over the starting quantity, which was 5.77. Okay, So again, we have a division problem. So let's take out our calculator here. And we have 0.43. And then we divide that by 5.77. Hit enter. Okay. All right, and again here we have a decimal. Here we're not dealing with, so it's no longer a money here, but in terms of, it's actually a percentage of change. All right, so here what I'll do is I'll take 3 place values. So I'll do 0.075. So the relative change, and again, let's change that to a percent, is 7.5%. So it went up by 7.5%. Okay, so that would be the relative change. All right, and again, this is helpful in comparison because now it's in relative values, right? Percentage-wise. All right, so let's take a look at the next 2 years, from 2005 to 2006. All right, and let's start with the absolute change. All right, so absolute value, and again, that's ending quantity, which in this case was 8.45 trillion. And 7.91 trillion. Okay, so here we get 8.45 minus, what was it, 7.91. Okay, so we get 0.54 trillion. All right, and again, $0.54 trillion or $540 million is what that's representing in terms of the debt. Okay, now it looks like, oh, well, that actually is, it looks like that increased. It did, dollar-wise, 500.54 trillion, right? But let's actually now, let's investigate further and let's look at the relative change. And then we can see why just kind of these raw numbers without any context don't tell the whole story sometimes. So relative change, we'll take the absolute change, right, and over the, what was it, the starting quantity. Okay, so we'll take out our calculator and we'll calculate 0.54 divided by 7.91. Hit enter, and here we have 0.0682. And actually, let me keep it consistent. I think I only went 3 place values. Yeah. So here we go. Let's do that. Okay. And that represents a relative change of 6.8%. All right. So now here, so we've answered the question here, and they ask us which year saw a larger increase in federal debt. Well, if we just talk about dollar amounts, it would be from 2005 to 2006. Now, if we think of in terms of actual size, that actually happened from 2001 to 2002. And that corresponded to a percentage-wise, a 7.5% jump. Whereas opposed in 2005 to 2006, it was only 6.8%. All right. So just kind of be careful here when we are dealing with these numbers that they're comparing quantities that aren't necessarily the same. Right, so it's kind of nice to have a base to compare it to, and that base will usually be in terms of the relative change, right? Relative to whatever we started with. All right, it's a good way to compare numbers across different data sets. All right. Thank you.